Okay, so it's been a while since I've made a video, but I'm back with a video on inclined slopes. This is going to be part 1. Um, inclined slopes is the hardest unit of the year. And there are, a lot of... It's hard and it's confusing. So I'm going to try to make it least hard and least confusing I can possibly make it. And that starts with one thing. Right now, okay, I need you to pause the video, and I need you to take out your formula sheet and write these down under the forces section and label it inclined slopes. So I'm going to explain this later on in the video, but it is very important that even if you don't watch the whole video, that you write these down, because these will save you a lot of memorization, a lot of time studying, basically. So, what I wanted to explain... Sorry. What I wanted to explain first is free body diagrams. So, this free body diagram is basically what was in the notes. This is what will get you full credit. This is what a teacher is looking for on the test. So, you have basically two directions of forces. So you have your object in the middle, and then you have basically 4 forces, one on each side acting on it, sometimes 2 on this side over here. So you have your force of friction here opposing your force of gravity X and your applied force here. There'll always be force of gravity X, just sometimes there's applied force, sometimes there's not. But that comes down to reading the problem. So, yeah, you have force of friction and force of gravity X and applied force opposing each other. Right, friction is trying to hold the object on the hill, up the hill. Gravity and the applied force are trying to push it down. So then you have your force of gravity Y and force of normal force also opposing each other. The gravity Y is holding it while pushing it against the hill or slope, and the normal force is pushing it back up. They are equal and opposite of each other in this situation. And then to make sure that teacher recognizes that you definitely understand this, put this in the corner, showing the directions of forces. And then also the angle over here in the corner. Do not forget about that. And then if there is acceleration, final step right here. And then if you're really feeling fancy, you can put plus in this direction, minus in this direction. Okay, so you've drawn your diagram. You should be able to do that before you even read all of the problem. If you just see it says inclined slope, boom, you should be able to draw that. That just comes down to basically memorization. So what I would do is just draw a bunch over and over until you get it down. Like, that's really the only way. So that's the first step. Step 1, draw your diagram. Once you draw it, you basically get it out of the way. Now, second step, grade the problem. And you've got to understand that physics teachers, they are looking for you to not just read the problem, but analyze it. So I've written down problem 7 from page 7. And what I'm going to do is I'm going to analyze it and write down all my givens. So right now, I can tell you there are 5 givens in these 3 sentences. Right? So, we start out with the first one. This one's pretty easy. It says, so the problem goes, a 325 kilogram tree is slid along a ramp with an angle of 41 degrees. The coefficient of sliding friction is 0.24. Find the force to slide the tree down the ramp at a constant speed. So, the first given is right at the start, and that's the mass. If you see kilograms, obviously that's mass, so you know that that's the mass. So, write down that m is equal to 325. And for every problem, I would do this. Write down all your givens in kind of a box like this. It helps for step 3, which I'll show you in a bit. So, yeah, if you see kilograms, you know it's mass. Next, we go a little farther down. With an angle of 41 degrees. This one's pretty easy. It tells you angle 41 degrees, right? So you know theta equals 41 degrees. Most of the time, it's not going to be that easy for most of the givens. Right, next we get a little harder. You really have to read the problem multiple times. So here it says coefficient of sliding friction is 0.24. This whole sentence is one given, and that is mu. If you are doing an inclined slope problem and you see the word coefficient, that means mu sub k. You don't have to worry about it being mu sub s when it's an inclined slope problem. So if you're doing an inclined slope problem, you see coefficient, boom, it's mu sub k. Now, this is where some people get stuck. The last problem, the last sentence is just letters. There's no numbers, no nothing. What could the last 2 givens possibly be? Well, I'll tell you that they hide it. Right? Constant speed, that means the acceleration is 0. It's been said all year, you just have to know that. And the hardest one. Now this one is tricky. You can take a guess right now. It is in the last sentence. It is the force to slide the tree down the ramp. That is the last coefficient. So I've talked about sometimes there is force applied, sometimes there's not. If there is, it will be mentioned in the problem, and you have to look for that. So here, it does not say anything about applied force. It just says, find the force. But you have to recognize that, well, there's only 2 forces that can be sliding the tree down the ramp. gravity X or applied force. And gravity X is always in a problem, so if they're asking for it, it's probably applied force. You just kind of have to get to that conclusion, which can be tricky. Okay. And the last part, which I talked about earlier, the need to know equations. So if you have these written down in your formula sheet, it will make your life so much easier. For some reason, our teacher wants us to memorize these. No, I'm not memorizing these. So just write them down on your formula sheet, and it will save you so much trouble, especially because it makes the next step so much easier. So you have these written down on your formula sheet at least, and you have your givens written down over here. So the next thing that you need to do is connect the dots. You need to pick out equations that you're going to use. The way you do that is by looking at your givens. So we're solving for force applied. We need to know the force applied. And ignore this because it's always going to be hard. It's not going to be that easy. We're going to use this equation. So that means that we also have to use the equation for friction and the equation for force of gravity X. And it just so happens that we have the angle, we have the mu sub k, and we have the mass. I'll save the drawing, but we have the mass. So we have everything for these equations, which is perfect because that's basically the exact amount of givens that was given to us. So that's basically what you have to do, is they give you a problem, you have to interpret it. Basically, you pick out the givens, then you pick out the equations to use. Now you might be saying, Evan, use this. Why don't you just use this? Well, you can't, because acceleration is 0. That would make the force applied 0, and it is not 0. So again, using a given to eliminate that option, it leaves us with the 3 that I've boxed in green. And I'll be solving them in part 2. But to give you a recap, you draw your diagram, you read the problem, you pick the givens out of the problem that you're going to need, you write them down on the paper, and then you take your cheat sheet formula sheet that you aren't supposed to have, but you have, and you basically choose the equations that you're going to use. That's all for this video. I'll see you in part 2.